Okay, the other way, if you don't want to use a data block editor, and the data block editor is great for one data block at a time. So if you've got 1 or 2 or 3 data blocks, it probably is nice to use the data block editor. It's pretty quick, it's straightforward. If you've got a lot of curves, though, it's going to be a little bit tedious because this only supports one data block at a time. It may be more useful to use the Excel data driver. This isn't an add-in. You just browse directly to an Excel file. The Excel file can have a .xls or .xlsx extension. So I need a minimum header above it. Here, the XLS file, which is the older format, supports 65,000 rows and 256 columns, so that's a limit. The XLSX file, which is a newer format, supports 1 million rows and 16,000 columns. So as long as you stay within these limits, you can either use the older Excel file or the newer Excel file. If you've got more than 1 million data samples, you're not going to be able to use this format, but the Excel is going to have these limitations. We need a header above the data, and then you're limited to 65K or 1 million rows, depending on what format of the Excel file you're using. It supports multiple data blocks, supports multiple different function classes, it supports waterfalls, and time histories are supported as well. So here's a couple of examples. So here's an auto power. I can see curve 1, so it's going to have to start with a curve 1, and then it's going to have a blank row between the data header. Then after the data header, it'll have a blank row. Then you'll see the units, and then after that, we'll see the data. So here's an example header. I've got function classes auto power. Point ID is component 1000 with a direction of positive X. Sample frequency is specified. Spectrum scaling is specified. Value is complex is specified. A weighting or linear is specified. So here I have linear weighting. Window correction mode, window is specified. X-axis increment, X-axis unit, and Y-axis is specified. So all of these may not be required, but there is going to be a minimal set you need to have in order to bring the data in. And then some of the other things are nice to have. If you're going to be doing math on the data, you might want to know what window was used, and you might want to know what window correction mode was specified. So some of these are optional, but some of them may be required depending on what math you're going to do on the data. Here's an example of an FRF where we specify the estimation method as H1 or H2. That's nice because if we do modal on it, we're going to remove the effects of the window. So it's nice to know if it's H1 or H2, and it's nice to know what window was used as well. Here it's got a uniform window, so we don't need to modify damping. If this was exponential, we'd be able to use that exponential window as well as the exponential parameter in order to compensate for the damping. Here we specified the point ID and direction, reference point ID and direction, and we have the units as well. Overall level, there's an example of an overall level. There's an example of a frequency spectrum, and here's an example of a time history. We've specified the point ID, a direction is blank, function class is time, number of lines is specified, X-axis increment is specified, X-axis unit, and Y-axis unit. Okay, so this is a small header we'd have to bring if we're bringing in time history. I have another example here of time data. And here the time data here is a minimal header here. So here I've just specified the point ID and the direction, function class as time, in the sample frequency or the X-axis increment. So here, really the minimal header set to bring in time data is really 4 headers. Unless you ignore the direction, then maybe it's 3 headers in addition to the units. You can also specify time with a variable X-axis as shown here. We can't process that, but if you wanted to bring in variable X-axis as throughput, we can do that as well by setting the X-axis to increment to variable instead of an X-axis increment to a value, or by using sample frequency. There's also an example here of an FRF data from mount data. This is a popular question I get for TPA is, I've got mount data from a supplier, how do I bring it in? Well, if you only have 1 or 2 curves, you can use the data block editor. Or if you have 5 or 6, maybe I want to use the Excel data driver with the header specified as an FRF. We'd have to pick the point ID on the passive side, reference point ID on the active side of your mount, specify the unit as force over displacement, either as Newton millimeter or Newton meter, and then bring the data in as real imaginary or amplitude phase as shown here. The one slide I skipped was a waterfall. So here we have an Excel header that has the x-axis increment specified, as well as the y-axis quantity specified, the z-axis quantity, and the z-axis range as well. And if I look at the Excel file, I see in row 123 the RPM values. So these would be your tracking values in RPM or time. Then we see hertz as the x-axis. We can see that the y-axis is meters per second squared. It's an amplitude format, and then we see the amplitude values specified in the table. The lower example is using decibel. So here we can see that the x-axis scale is linear, but the y-axis scale is dB, and then I would see the dB values in meters per second squared dB listed inside the table here. So if I go back to Testlab, and if I go to my navigator here, and if I go to my data import, and if I look at some Excel examples, here's some throughput import. And there I can see time. And then I can see 2 points here in time. So if I set this to be real, I can bring in 0.1. And if I wanted to, I can bring in 0.2. And they're pretty close here. So if I look at that Excel file, and look at that example there. So this is the throughput import file. So here's my Excel file. And here I have a worksheet called time. And then I can see curve 1 has this header with the sample frequency specified as 10 hertz. And curve 2 has the x-axis increment as 0.1. So if I wanted to change this, maybe I want to make it 100 hertz. And maybe I want the point ID 1 to be point ID new. And maybe I want to change this worksheet here to be something new. Rename, just call it time 2. Okay. So now if I save this, so I edited that throughput import file. So I'll go back to Testlab here. And if I refresh this, that would change a worksheet to time 2. And here I can see I got a new point ID. And I can put this in there. I do have the x-axis increment here. So you can see I changed it to 100 hertz. So now I can see that the sample frequency changed. And the x-axis increment changed. So you can edit files in Excel, and then you just need to go ahead and hit refresh to refresh that. If I look at some other sample files, here's an FRF. Okay, so here's some FRF data. So this would be maybe some example mount data. Okay, so there it's Newton over meter, or I could change unit to Newton over millimeter if you want to see what that looks like. I also have file types here. And then here I can provide this, and this is a nice file type where I put this in real over here. And I'm going to put this in preview mode. Okay, so these are all exactly the same curve it looks like. But here I can look at auto powers and I can see what they look like. I can look at coherences and see what they look like. I can look at cross powers, see what they look like. This is a frequency section. Here's another FRF. Here's an impulse response function. So that's a time history. I can look at sound intensity. I can look at minimal headers. I think the auto power it looks like. Octave data. I can look at octave sections, order sections. I can look at overall levels, PSD. Then I can also look at waterfalls. So if I open a waterfall here, I can bring this waterfall in. Okay, so then I can see I brought this waterfall in. It goes from 700 to 3000 RPM. Okay, so 700.23 to 3000 RPM. So if I look at that Excel file, so that was called file types, and we like to provide this to customers because it has a whole different types of file types we can import. Okay, so here's an example of the waterfall in dB. Here's a waterfall I just plotted that was an amplitude, and I can see that the RPM starts at 700, and it went to about 3,000 RPM. I can look at some of these other ones. This is the time data, the sound intensity, this is the order section, this is the octave sections. So it gives you an example of different file types we can import and what the header needs to look like.